Hey class, in today's lesson we're going to talk about exploring exponential models, which is found in section 7-1, part 1 of your book. Our objective is going to be to model exponential growth and decay. Alright, just a little vocabulary. It says an exponential function has a general form below with b greater than 0 and b not equal to 1. Now, by the way, that general form is located right here where it says y equals a times b to the x power. So in an exponential function, the base b is a constant, and the exponent x is the independent variable with domain being the set of all real numbers. So any time that we're talking about an exponential function, we'll always use this formula or this equation, y equals a times b to the x power, where b has to be between 0 and 1. Alright, so we're going to graph. I will go ahead and tell you the values that we'll choose to use here because we will use a table when we're graphing. But when we are choosing the x values for these tables, because there is no horizontal or vertical shift, we will surround 0. So we will choose values -2, -1, 0, 1, 2 to be able to give us a decent picture. So if I create a table, -2, -1, 0, 1, 2. And then I substitute that into the calculator. So this is really 2 to the -2, right? But anything to the negative power is going to put in the denominator. So it's really 1 over 2 squared, which we should know is 1/4. And if you like, it doesn't matter. You can use decimals. I'm fine with that. The next one is 2 to the -1st power. That's really 1 over 2. So that's 1/2. 2 to the 0. Anything to 0 we should know is 1. 2 to the 1st power is 2, and 2 to the 2nd power is 4. So then, of course, we're going to graph that information. And so -2 1/4 would be pretty low, right about here. -1 and 1/2 is about there. 0 and 1 is here. 1 and 2 is here, and 2 and 4 is located up here. And so that graph will exponentially increase. So this is an example of exponential growth. And I'll go ahead and write that now, even though really we're going to come back to the vocabulary later. But this is an example of exponential growth. Alright, and then the next one, we have y equals 1/2 to the x. So again, create a table. So it's -2, -1, 0, 1, and 2. This is 1/2 to the -2. Now to make this positive, I can just flip it and become 2 over 1 squared, which is going to give us 4. Because that's really 2 squared and 1 squared. So 2 squared, 1 squared, right? I'm distributing, right? So that'd be 4 over 1, which is 4. Alright, the next one would be 1/2 to the -1. Again, flip it. That will become 2 over 1 to the positive 1st power, which is just going to give us 2. 1/2 to the 0. We know anything to 0 power is 1. 1/2 to the 1st power is 1/2. And last, 1/2 squared. Remember, we're going to distribute those powers to both the numerator and denominator, and that'll give us 1/4. And it looks like I've run out of space, so I'm going to try and fit this in as best I can. Alright, so -2 is 4. -1 is 2. 0 is 1. 1 is 1/2. And 2 is 1/4. And so this one is very much obviously an example of exponential decay. So think about it. What would make this exponential decay versus something being exponential growth? Look at your formulas. What makes sense? What would determine if it's going to be growth or decay? If you're not sure yet, let's do some more examples on the next one. Alright, so it says what is the graph of each function? Again, we're going to use the same values. So we're going to use x and y, -2, -1, 0, 1, and 2. Alright, so it's going to be 4 to the -2nd, which we know is really the same thing as 1 over 4 squared, which is 1 over 16. 4 to the -1st, which is really 1 over 4. 4 to the 0 is 1. 4 to the first is 4. 4 squared is 8. I'm going to try and graph this below. Alright, so we're going to have negative 2 and 1/16 is hardly going to come above the line. Negative 1 and 1/4, just a little higher than that. 0 and 1 is here. 1 and 4 is here. And 2 and 8 is here. So this one again is an example of exponential growth. Okay, let's look at the next one. Again, create our table. And I do want to be sure and very clear about this when we do our homework. Be sure that you are creating your tables. Okay, so this is 1/3 to the negative second, but we know to make that a positive, we're going to flip it over. So 3 over 1 squared is going to give us 9. 1/3 to the negative first is really 3 over 1 to the first, which is 3. 1/3 to the 0 is 1. 1/3 to the first is 1/3. And then 1/3 squared is, right, the square goes to both the numerator and the denominator, that's 1/9. So again, when you graph, we really need a taller y-axis. Okay, that's negative 2 and 9, which is way up here. Negative 1 and 3 is here. 0 and 1 is about there. 1 and 1/3 is about here. And then a 9th is barely off. So this one's going to kind of flow like that. And again, this is an example of decay. And the last one, negative 2, negative 1, 0, 1, 2. We're not going to change our values. Even though we see this 2 in the front, you'll see what the 2 actually does. Okay, so this is really 2 times 3 to the negative second. It's the 3 that's being raised to the negative second, so this is really 2 times 1 over 3 squared. 3 squared is 9, so this is really going to be 2 times a 9th, which would make this 2/9. Okay, let's look at the next one. 2 times 3 to the negative first, which is really 2 times 1 over 3, which would make this 2/3. This next one is 2 times 3 to the 0. 3 to the 0 is 1. We know 2 times 1 is 2. 2 times 3 to the first. 3 to the first is 3. And 2 times 3 is 6. And the last one, 2 times 3 squared. 3 squared is 9. And 2 times 9 is 18. So then we will graph. Alright, so let's graph. And again, I'm going to do a little bit of a shorter graph because we really don't even need to see the negative side. Alright, so negative 2 and 2/9, still very low, lower than 2/3, we should know. Negative 1 is 2/3, so a little closer to 1. 0 is 2. 1 is 6, so 1, 2, 3, 4, 5, 6. And then 2 is way up here at 18. So this one will go up there. And this one again is growth. Now, I'm hoping you've been able to determine now what makes something growth versus decay. Okay, so if we go back to the formula, y equals ab to the x, remember it is your b that is going to determine if it's growth or decay. The growth would be that b is greater than 1. And if it's decay, it's between 0 and 1. Okay, And then the A in this case is really just going to kind of stretch. Okay, so the A, yeah, it kind of determines the stretch factor here. Also, A is going to be your y-intercept, right? So in all the other ones, A was 1, right? Because there's a 1 here in the front. There's a 1 times 1/3, 1 times 4. But in this case, it was 2. And 2 ended up being your y-intercept. So we're going to say that A is your y-intercept. And that's that. Let's keep going. All right, a little bit more vocabulary. It says 2 types of exponential behavior are exponential growth and exponential decay. For example, exponential growth, as the x value increases, the y value increases. For exponential decay, as the value of x increases, the value of y decreases as it approaches 0, which we just explained. All right, and on this one we get a visual. So it says the exponential functions shown here are asymptotic to the x-axis. An asymptote is a line that a graph approaches as x or y increases in absolute value. All right, and then we have our formulas, which, you don't really have to look at this, but the main parts, again, is, if you want to know that it's growth, it's greater than 1. If it's decay, it's between 0 and 1. Notice that A stays the same, but that A is the y-intercept. All right, so on here now we're doing is just identifying if it's growth or decay, okay? So it says identify each function or situation as an example of exponential growth or decay. What is the y-intercept? So again, we should look at our B term, right? This term here is going to determine if it's growth or decay. If it's greater than 1 is growth. If it's between 0 and 1 is decay. So this one is decay. And the y-intercept is 0, 12. Okay, on this next one, because 2 is B, this is growth. And our y-intercept is 0 and 1/4, or you can say 0 and 0.25. Then lastly, it says you put $1,000 into a college savings account for 4 years. The account pays 5% interest annually. Because it's growing, it pays on the interest annually. This is, again, an example of growth. And this y-intercept is 0, 1,000. Or if you want to put the dollar sign, you can, but probably really shouldn't. And we're done. Let's do the try. All right, so again, there's no big difference here with the formulas. I want to point that out. Just because the x variables on the inside does not make it any different than what you saw in the last one. It means the exact same. In fact, it even more specifically tells you where that exponent is going. Okay, so again, this one is growth, and the y-intercept is 0, 3. This one is decay, and the y-intercept is 0, 11. And the last one is also growth, and this one is 0, 2,000. And we are done. Guys, remember, if you need any help or if you have any questions, please come see me for tutoring.